So today we're actually going to do a titration. So a titration in chemistry is normally between an acid and a base. And the reason you're doing this is that you want to figure out the unknown concentration of one or the other. So either you're acid or base, you're not sure of the concentration, you do a titration, you'll know that concentration to a high degree of accuracy. So in this lab right here, what I'm going to do is I've added some sodium hydroxide. This is actually 0.1 molar sodium hydroxide. I've added to a burette. So with titrations, we use burettes. And I've already added 25 milliliters of hydrochloric acid to this Erlenmeyer flask. I'm not sure of the concentration of hydrochloric acid. By titration then, and a little bit of stoichiometry, we're going to figure out this exact concentration. Now, a couple of things. When you're adding this base, you want to add it so that it neutralizes all that acid. It's called an equivalence point. The amount of acid and base are going to be equal. I don't want to add too much. I don't want to add too little sodium hydroxide. So I want to stop at the exact spot. Now, since they're both colorless, the way I'm going to know when to stop is that I'm going to add an indicator. So this indicator right here is phenolphthalein. Now, phenolphthalein, it's going to be colorless in acid, and then it's going to turn pink when the solution is basic. And so when the solution stays basic for about 30 seconds, I'm going to stop. That's actually called the endpoint. So the endpoint is where you see a color change. If you do this titration correctly, it should equal to the equivalence point, or be very, very close. Maybe off by 1 or 2 drops, etc. So I'm going to add about 3 or 4 drops of the indicator. So 1, 2, 3, 4, 5. Notice that when I add to hydrochloric acid, it's colorless. Now, as I start adding the sodium hydroxide, the solution is going to start becoming pink. When it stays pink for 30 seconds, I'll stop. That's going to be the best endpoint, and that should be pretty close to the equivalence point. So a couple of things when I'm doing this. I like to make this a steady stream, or not really a stream, some droplets. So adding some droplets to this. I like to put a white sheet of paper underneath so I can kind of see it becoming pink. It's a little bit hard to see from the video, but as I add the sodium hydroxide, as it becomes more and more basic, the solution starts becoming more and more pink. When you swirl it around, it disperses it, so it doesn't stay pink. But eventually, when the solution becomes basic or right at that end point or equivalence point, it should stay pink for about 30 seconds. Also, when you're doing a titration, you want to set it up so that the volumes that you need to reach the endpoint are about 20, 25, 30 milliliters, something along those lines. You could use a little bit less or a little bit more. You don't want to do a titration in which you have to use just a tiny amount of base or acid, because then it increases the risk for making mistakes or inaccuracy with that. So I always kind of shoot for about 20 milliliters, 25 milliliters, etc. Just keep adding this. And again, you may be able to kind of see it's kind of getting a little bit more pink as we go along. Again, swirl it. The reason we're using an Erlenmeyer flask is that when you swirl it, it doesn't spill over. So if you use a beaker, you would have all kinds of messes with that. As you start getting closer and closer, you start adding a little bit slower. I mean, I can kind of speed up a little bit, I think. So let me kind of slow down. There we go. Again, I like a nice droplet stream with that. Now in class, we'll do these calculations. We'll show this acid-base reaction, and this is why we want to use stoichiometry. We'll look at the mole-to-mole ratio between the acid and the base. We're going to use molarity, which is moles over liters. Basically the same way we've been doing when we do stoichiometry, just a little bit different ways of getting to moles as we did in chapter 5. So this will be chapter 6 stuff in terms of the solution stoichiometry, they call it. So now I'm getting a little bit closer, staying pink a little bit longer. And again, when you start getting close to that endpoint, which means that equivalence point, then you really want to slow down. Let me slow down a little bit, actually. I'm getting close to that. Staying pink a little bit longer. So now you can kind of see it maybe a little bit longer now. Oh. Again, just swirl it to disperse it. What you don't want to do is overshoot it. You want to get as close as you can. So you try to get within 1 or 2 drops of this. Okay. So actually I'm going to slow it down now. You can start seeing it stay in pink a little bit longer. I did this once in real life. I had a friend of mine, he made Tabasco sauce, and he wanted to figure out how much acetic acid he put in there. So I did a titration with sodium hydroxide. It worked exactly the same way. Okay, now it's getting closer. Now you can start seeing it. Okay, and again, you want to do it for just about 30 seconds. So I'm just going to add there it is, right there. And you notice that one drop right there, one drop, and then it stayed pink. And again, you would like to do it for 30 seconds. If you miss about 1 or 2 drops, since we're doing such 20, 25 milliliter volumes, it's not going to make any difference in the calculations.